Swayam Prabha. Digital India. Educated India.
Hello, welcome to this course ME6102 on design of mechatronic systems. What we are going to see today is mainly the introduction. Part of that is what is learning. We'll see what opens up for us, and then motivation for this learning and the contents of this course. Okay, so these are mainly things that we are going to see today. So my name is Prasanna Gandhi, and I'll be there as an instructor for this course with you for this semester to go. Okay, so let's begin here. Let me switch to the slide mode again. Okay, now first let us ponder over this thing. Have you ever understood this mechanics of learning? How the learning happens? Okay, what is this learning? Okay. So any guesses? Can you see, think about how exactly when we see or you read something or you listen to somebody, what is a way the learning happens in the process. Okay, if you kind of ponder over closely, you'll understand that it is not about just some kind of information. It is actually taking you to what you already know and adding something more to it. Okay, so it is something moving from something known to something unknown. Okay, so that's why you need some kind of a background for learning anything. Okay, so child cannot be sitting in this class with you, right? I mean, he or she may not understand anything talked about. Okay, but there's this basic some kind of a background. If you have, then you can connect with that background to something unknown, and you grasp little more than what you have known already. Okay, so this we understand this process. If you understand this process very well, then it's very smooth journey. Okay, for enhancing your knowledge. You'll not have a situations of panic, because okay, for understanding something you need some background. Okay, so it's in some way expanding your common sense. Okay, so this is again another part of learning. See, from childhood, we have this kind of a common sense. For example, when you are driving a bike, or when you learn first to kind of ride a bicycle. Okay, you don't need to know the fundamentals of mechanics or force, or the kinematics or dynamics of the systems. You learned it by some way. Okay, with that kind of a common sense, okay, if you kind of tend to fall on one side, you need to do something to not make that fall happen, and somehow you kind of master that skill. So you don't need really these fun days to kind of get a sense. Okay, so this common sense is what I'm talking about here. We should not lose it. I mean, I found over my experience, many people they tend to lose this common sense instead of expanding during the process of learning the engineering courses. Especially deep mathematical courses, you tend to believe math more than your common sense, and then that's where the things start kind of a little bit moving away from doing any useful things out of whatever you are doing. Okay, so you need to be aware about these two things, the learning process is going from known to unknown, and this is a common sense that we already have something within us. We want to kind of expand it more. Another example I can give for this common sense kind of a thing is the sense or feel for numbers. Okay, so if I say 1 meter or 1 mm, you understand what it is, right? You have a feel for what is 1 mm and 1 meter. But probably if I say the same thing for acceleration 1 meter per second, or that it's very a little bit hard to kind of get a feel for that. So we have to develop this kind of a feel, and that feel is very important for designers. Okay, so we'll see a little more about that as we go along. Okay, what it is not just the information, it is not your memory. Okay, and it is not moving from unknown to unknown. So if you are something is being talked about, and you are not able to connect it to your prior knowledge, or it is just kind of making no sense to you, that means probably you need to kind of go back a little bit, one step, and do read about the prior background necessary to understand that. Okay, so that if you understand this, then you'll not have a difficulty. So when you don't feel that you are understanding well, then you go back and do some background and come back again to this. Okay, so this is what we'll do. Okay, then let's move on to the next question. Now, what is the way, how do you understand things? Okay, see, typically what you do, while to do study, you start reading the books. Okay, then maybe some of you may be seeing something about some concepts, you see there's some practical thing happening, or some kind of experimental thing happening about that concept, and then understand the concept. Okay, but does it give really great understanding? So you just see this some kind of a Chinese saying, where whatever you read, you tend to forget in in time. Okay, so this time may be a little small for some people, maybe a little large for some other people, but whatever you have read, you will tend to forget eventually as the time progresses. Then whatever you see, you'll remember. Okay, so if you have observed some phenomena happening, that creates much deeper impression in our mind than just reading. Okay, then actually when you do the stuff, then you understand. If you are building some setups, or building or you're actually working out that experimental phenomena yourself, while doing, you understand much better. Okay, then that understanding is kind of somewhat irrefutable. Anytime, even in the middle of the sleep, you are awaken and ask something about it, you will not have any problem in kind of telling that. So that is a way you say, okay, that is the way, there's a point, you have understood the things really well. Many times we say, okay, we have understood, but actually reality, somebody asks some questions about it, then we understand, oh no, we have not yet understood. Okay, so like that, you need to kind of see what you call understanding, and how do you get to the understanding thing. Okay, and we will do in this particular course is all about doing and understanding things. So we'll do a lot of stuff, may be simulation, may be some small experimentations at your home. We'll do with experiential learning. Okay, through experiment we'll start learning a lot of new things. Of course, there'll be mathematics to back up the things, and understand what part of mathematics are really important and not. We'll see as we move along. Okay, so for this course to kind of have you a rich experience, what is expected out of you? Okay, the first and foremost is ethics. Okay, so this is something which will not compromise at all. Okay, this is for your own kind of a rich understanding and learning experience. This will very important not to kind of tamper with your ethics. Okay, and you can help others to clear fundays. Okay, that actually helps you to kind of enhance your clarity of understanding. Okay, somebody asks you questions, it's much better kind of a way to kind of think over and give answers. While answering, you'll find that okay, your clarity about those fundamentals become much better. Okay, at least as instructors we have this experience. Every time we teach the same course, even if it is the same course, there are some things that we learn from the questions that the students ask. Okay, so it's good to kind of do that kind of a small process in small way as possible for your friends. then now we cannot be in class physically, but at least you can be physically there during the class hours, so that we can have whatever possible best interaction possible when we are kind of having this interaction session during our class time. And very important that if you have doubts or questions, you will feel free to ask. It may be common for many people, and you need to be aware of this common sense feel I was talking about, that you say, for example, you throw a ball from your inside your house, you throw a ball to touch your terrace, touch your ceiling, and it comes back. Do you have a feel, okay, what is the velocity it will hit the ground? Okay, and again after hitting, what is the velocity it will bounce back? Okay, depending upon the material of the ball, there will be a lot of different kind of things that are happening there. Can you get a feel for this these phenomena? Okay, of course you know how to kind of do the number crunching on that and get to those numbers, but without doing any number crunching, without getting into equations too much, can you kind of get a feel, oh, this will go by this velocity of 1 meter per second, or 2 meter per second? What is the velocity? Or when you are riding a bike, what is the kind of a speed that you are going in meter per second, for example? So those kind of a feel for numbers is what will help any designer to get the design ideas conceived in a way that they'll be more feasible. Okay, otherwise we conceive a lot of ideas, but then just some simple top hat calculations, we find those ideas are not really workable. Okay, so to get to the ideas, multiple ideas, innovative ideas, but they are workable. Okay, they are at least somewhat workable. Okay, you need to do a little more kind of a thing to kind of make them perfect, but you will not waste too much of a time in conceiving ideas as a designer which may not see the light at the end of the day. Okay, so that is a kind of idea for getting the feel for different phenomena and different numbers. Okay, and also you should you are free to give feedback anytime, even anonymous, or whatever way you want to give, you can post it anytime. Okay, so this feedback will help to kind of to tune the things for your particular kind of a test of learning. Okay, all right. This is a slide about communication. Okay, so when I'm saying some words or saying something, okay, you may listen to these words multiple times. They make some kind of a picture or sense in your mind, but what I wanted to speak, that intention behind may be different. Okay, so we'll become aware about this fact, that okay, the picture actually is different, but the words are saying something different. So we can ask and questions and clarify this understanding and learning here. Okay, so let's move on. Okay, now the question here is is why study design of mechatronic systems? Okay, so you can kind of ponder over this. Okay, why do you think you are here, okay, for this course? Okay, what prompted you to really come here and maybe at least kind of get a introduction lecture attended, or feel for the course? Okay, what do you think? Okay, just ponder over this. You may have some answers with you. You may be writing them out or thinking them out, but okay, so let us think from just general kind of a philosophy perspective. What are the things that get importance in the different periods of time, okay, in terms of this technology? Okay, so you'll find that the technologies that drive the markets, market economics in some way, they start kind of gaining more and more importance, and then the old technologies which are there, like they kind of fade away. And so this mechatronics is like doing that kind of a difference. Okay, so the technologies which are giving you higher productivity and at a lower cost, okay, that are going to get the market better. Okay, so you can see that the increasing demands on quality and productivity, okay, that forces any technology, that drives any technology. Okay, and in this particular case it is mechatronics or automation. Okay, so if you see all the things that are happening in these different domains, like automobile domain, energy space, aerospace applications, they are all kind of now getting like drastically changed by these developments in the area of mechatronics. Okay, or they are getting more and more mechatronic systems into them. Okay, and the next question is, okay, like was it not known before? Why it is getting demand only now? Okay, the answer is, like if you see the over the period of years now, like there is a decrease in the cost of IC and microprocessors. Okay, and they are available now at a throwaway price. Okay, you can even buy a lot of microprocessors as a sample boards without paying anything, and like you can work with them. So this low cost implementation of control is what is possible very easily now, and that is what is kind of like its main game changer in all these activities. Okay, then other thing is, like many new features and products that were previously unthought can be possible. There are a lot of examples one can cite. I mean, you can start with ATM machines, or like your car, lot of systems in the car, like modern cars. If you see, there are so many kind of small control systems which are in place, right from the fuel injection, electronic fuel injection, to auto drive mode, or this the hands-free drive mode. A lot of like these new features are coming in the automobile industry, which are previously people might have, like 30-40 years like before, people might not have thought that this could be possible. And there are many future directions which are like very exciting in this domain, I would say. With Internet of Things, there are increasing smartness now rests with devices and the systems themselves. You don't have to kind of repair the system, but the system will say, like that okay, it needs repair, or you don't need to do the maintenance of the system, but system will maintain itself. That kind of a thing could be possible with the developments in IoT sector that are happening. And other thing that is happening is in the machine learning domain, which is like very interestingly changing, like lot of ways in which the things are done previously. So you might have kind of seen them already, but maybe we can kind of like have some examples of these as we go along in this course. Okay, now if you see what are the different applications of mechatronic systems, okay, you can like see some of the industrial applications. Okay, there are many like assembly lines or process plants which run with like these mechatronics at their heart. Okay, so maybe let us observe this video. Okay. You can see like so many robots which are working in coordination with each other. Okay, there is sound behind, we cannot hear the sound. Okay, so you see that it is doing some quality inspection and segregating components based on the quality of the products that are being running on the line. So this is like assembly line for like different products actually. So if you imagine this operation to be done by a human being, it's going to be too much of a what you say, drudgery kind of a job, okay, like doing the same thing over and over again, and that is completely being saved by this process. Okay, so this is very interesting way, like these product lines, this is a ABB industry, kind of a about courtesy to them. So you see the way this robot is made to work. It has a flexible links there. I mean, they are not very flexible, but they are somewhat flexible. But they are working in there. It's like in a parallel kind of a configuration, and because of that, this robot is kind of working very fast at very high speed actually. Okay, that can be possible for such a kind of a system because of the lightweight flexible linkages. Okay, and it comes with a so here, like now there is a additional image processing kind of a application going on. So with this image, like you are identified like some kind of a products, and then like they are placed into their packages in a very interesting way. Some kind of algorithms being worked out. You can see that here. So how like these packages are fed with proper products placed inside them, and handling these kind of a soft objects, very kind of interesting technologies would have gone in designing or developing these products and processes, and like further the complete mechatronic system around the process. Okay, so maybe we'll pause here for this video and come back to our presentation. So what you have seen is one of the industrial applications. We have such a lot of such kind of like applications in industry, and there are a lot of domestic or like consumer applications for these systems as well. Okay, so a lot of these new gadgets that you see around, I mean, you must have used like plenty of these yourself. So I'm like giving some list of some gadgets here. Okay, so CD-ROM drives, for example, is one of my favorites. It's very interesting technology sits there. Very refined kind of a optomechatronics kind of a system is CD-ROM drive. So it has to read the data from surface of a CD, which is placed in the one kind of one single spiral which runs over kilometers on a CD-ROM drive. So we'll talk about this a little more in details in some classes to come. Then maybe we'll look at some more kind of like some products. Okay, this kind of looking at these actually designed products will help us like tune like what is a way or thinking philosophy of developing this kind of or designing these mechatronic systems ourselves for some different application. Okay, so from that perspective we'll look at like many different existing applications. Okay, so that is what the point I was coming to now. Like how do you understand like these systems? See, for designing we need to have this understanding of these systems first. Okay, so see there are multiple ways. Okay, so one of the ways is like going through like entire fundamentals and doing like a lot of different allied courses or different allied topics related to these, like mathematically or theoretically studying them all, and then come back to a system and like see how these fundamentals are taken into that system. And other approach is like you can directly go to these systems, experimental practical world, and learn from nature. You just see like how these systems are designed. Okay, observe things keenly and carefully, and you will see that like the things do make this kind of a common sense. Okay, so we will look at these systems from that perspective, like okay, observe keenly. Okay, why this particular feature people might have put in this system. For example, CD-ROM drives, why they have like something like compliant mechanisms. Okay, So these are the kind of questions that you can ask yourself. Like once you see, okay, how this is placed, how this is designed, how this is, what are the components that are used, okay, why those components only, why not any other kind of components. These are the kind of questions you typically tend to ask yourself, and observing this keenly, finding the answers to these questions, then you'll get to know some very interesting kind of a fun days that commonly will be difficult to teach in any of the formal theoretical kind of a course. Okay, so that's what our approach would be, that okay, we understand the mechatronic systems from their already existing knowledge that is there in the domain in the form of many different products. We will learn from that, and then while designing new products, we make use of the fundamentals that are learned from already existing kind of a products. Okay, so we use our existing knowledge or learning and apply it to whatever these observations that we are carrying out, and then expand our domain of understanding. That is a process that we'll go through. Okay, at least for to begin with, we'll do that for a couple of systems, and then we'll get a feel of that, and then we'll see how do we kind of apply this now to a new kind of a system or products that we want to develop. Okay, so this all is learning here will come out of some fundamental laws, some basic kind of laws that you must know, then some keen observations of existing stuff and things around, and then of course the common sense and simple kind of a geometry and calculus fundamentals that you need, and microprocessors fundamentals is what again we will have as a prerequisite here, and signal processing fundamentals is will built in this course. Okay, so all these things put together is sufficient for getting a really interesting mechatronics application kind of going. Okay, all right. Now I would like to want you to kind of look at take some of these systems. So you can take one or more of these systems and think, okay, how they would be working. Okay, and I want you to not directly go to see right now so much of information is available on the net, and we tend to kind of immediately go, oh, this is, and find out, okay, how things happen. Okay, I don't want you to do that. I mean, I want you to first think about what you think. Suppose whatever knowledge right now you are to design some kind of a application such as these. What comes to your mind first? Okay, what is that you will do? See, why we need to do this, because that will, when you see now after this thought, a lot of questions will be raised in your mind, and now when you see this, let me switch on to myself. So when you kind of look at this, think about these systems yourself. Okay, say for example CD-ROM drive. I take a CD and see, okay, well, these are the tracks that might have so I want to read some tracks. Okay, what is the system that could be there inside that will have a head or something to position to kind of read the track? Okay, it is touching or maybe non-touching, I don't know, but what kind of system would be existing. So if I want to design, will I design the system which will touch the CD surface and then get the information, or I'll design a system which will not touch the surface and get the the information out of the CD. Like that, you think about all that is possibility for based on whatever knowledge that you have to begin with. You will start kind of you may be wrong in doing whatever things, doesn't matter. Okay, your thinking is what is more important here. That thinking will generate a good mindset inside you that will be now very ripe for accepting registering the solution that are existing. When you kind of actually go to the website and look at these solutions that people have actually given, and so if you go to this website of howstuffworks.com, you will find most general kind of information about how these systems work. They may not have very particular kind of information, but you'll find essentially what is needed to kind of see, okay, how people have kind of designed such systems and what technologies are in place to get this thing working. So this is the exercise that I would like you to do. Okay, so I'm switching back to the slides again. So you can look at all these systems, or maybe like as many possible systems, and some of them will take actually for like more detailed kind of a study, okay, as we progress in this course, okay. uh, so for building mechatronic system, what you need, okay. So first and foremost is like conceiving idea, okay, or like given an abstract problem, you first conceive idea in terms of like defining like, okay, what is exactly problem that is to be solved, and can I divide it into many sub problems to be solved, okay. And for each of the sub problems, I'll kind of give or conceive new some idea or solutions for that, okay. And so this ability to kind of like given a bigger kind of a problem, to break it into like many kind of a smaller sub problems is very, very important. We are not tuned to that kind of a thinking so far, because like many courses, whatever you are going through, have typically like given this kind of a problem defined completely, okay. And when the problem is defined completely, you solving it is easy. But how will you define a problem in the first place, okay, to solve some kind of a abstract kind of a application, okay. How do you define the what is the problem to be solved in terms of like mathematics or technological problem that is to be solved, okay. That is a task, is we are not used to that task, I would say, okay. So we should kind of like look at how do we kind of develop the skill to see through, okay, what is the problem that is to be solved. And then other kind of skills that we need for is ability to build like or manufacture things, okay. So in both in the domain of mechanical and electronics, we need to have this kind of some kind of a skill set to know what kind of manufacturing ideas can be used to kind of like develop some certain things, okay. And so we'll take this example later, like building, you have to build some kind of a motion control platform for given some specifications, okay. That is an example we'll do for many different kind of specifications. What are different technologies, how does specifications change the technology for like development of such things, and okay. So like that we'll kind of like study from really a different perspective that you might not probably have been exposed to so far, okay. So that is what like we'll look through in this course. So now coming to course contents, like as you might have read in the syllabus also, that we'll look at like first these applications and like different constituents that are necessary to kind of like build these mechatronic systems. So sensors, actuators, like your plant and controller, okay. So you need to have a fair understanding of these, each of these elements, and then like you'll understand how they can be put together to kind of like drive any interesting application or solve a problem, okay. So we'll have some kind of a hands-on experience. Now we'll see how this hands-on experience can be built. So for this we may not have much kind of, we'll do mostly like some kind of a video based understanding here, or some kind of a I have some actually open stuff here. I'll put some kind of a slides about this, and then like we'll discuss like what we observe, okay. So we'll do that with a couple of such systems like CD-ROM drives, hard drives, or some kind of systems like that, okay. Then we will study a very important aspect of mechatronics, which is like integrated mechanical and electronics design philosophy, okay. So typically we are accustomed to thinking only in mechanical domain or mechanical engineers. All electronics engineers only in the electronics domain they'll think. But now if you want to put together mechatronic system, like your decisions in mechanical domain may get affected by like what is possible or not possible, or what is easily possible in electronics domain, and vice versa, okay. So these aspects is what is very important for mechatronics engineer to understand, or like mechatronics system designer to understand, so that he or she can put together a system which has plus of both the sides, like or you are not compromising on too much into for demanding some kind of a way of the way mechanical things to be done. You are demanding too much on the electronic side. No, that is not. There should be well balanced kind of a design, or somewhat kind of a optimum design from both the domains perspective. Okay, that's what we will learn then. Then microcontrollers will get into much more details about. Then we'll look at the quite a good amount of details or time we'll spend on how do you kind of design control for practical working of systems. See, control traditionally will have a lot of mathematical control algorithms. If you open if you just search this area of control, there are tons of several papers on many different kinds of controllers people have developed and designed. Out of them, only some subset would be actually worthwhile to look at from the practical implementation perspective. All others are theoretically working fine, but in practice they may not have any kind of possibility or feasibility even to kind of implement. Okay, or even if the feasibility is there, it is at such an additional cost that it is prohibitively restrictive. Okay, so we'll look at these controllers which are mainly practically feasible for controlling say for example to control linear system or non-linear system with a rigid body, okay, which is fully actuated. What is the best control law? Okay, those are kind of questions that we will deal with in these discussions. Okay, or if you have under-actuated kind of a compliant system, what is a kind of a control that we'll do so that we achieve our application without having too many disturbances or vibrations coming out because of the compliance in the system. Then there are non-linearities which are practically unavoidable, which is like friction, backlash, and noise. So how do you kind of deal with them? And finally, some fundamentals about digital control. Okay, the way the control is implemented. See, whatever mathematics that we do is all continuous in nature. Okay, and even what you are learning in Mac course or you have learned in Mac course is all in a continuous domain. Suppose now, but actual practical implementation is a microcontroller which is doing in a sampling time implementation. So what is happening to the system dynamics because of the sampling? Okay, that is a domain of discussion in the digital control. So we'll touch upon some of the aspects there. And finally, what we need is the signal processing for mechatronics. Okay, so these are the things that we are going to kind of look at. Okay, so this signal processing is an integral part of any of the mechatronics system. Okay, you need to have a good understanding of signals, their sampling rates, and how do you process them to kind of make sure your application is running in a best possible way. And then maybe if your time permits, we can touch upon some of the advanced topics there. Okay. Apart from this, if you feel okay, there is something that you would like to kind of look at in this, then maybe you can propose and we'll take a look at. Okay, these are the course goals set. Okay, so that's what I've been talking about. Conceive this new mechatronic product. Okay, is what we'll have this skill that is to be take away from this course. Okay, how do you kind of conceive this and develop that idea further, okay, to realize into a product. Okay, so you'll be able to control actuators like motor, voice coils, in a closed loop, and understand these are more details, kind of small sub goals or sub parts of these goals that or skills that you'll learn as a part of this course. Then how do you interface sensors with microcontroller? Okay, using various different kind of interfaces that are there. So you may not have closed loop control application, but you just have some kind of a observation of some phenomena in a nice way to be done. This will be very helpful. Or if you want to develop closed loop control, of course this will be definitely helpful. Then develop skills to choose controller, I mean the sensors and actuators and microcontroller for a given application. Okay, so this is again another very useful practical kind of a skill that you must have to kind of get a good mechatronic system working. Okay, then next skill is about developing reasonable mathematical control or model first, and then the control and or control amenable model here I'm saying for system under condition, and then ability to design a control again. Okay, and once you have designed controller, then you need to see through some signal processing aspect for control implementation to kind of get the smooth working of the entire system going. Okay, so these are more kind of skills that you'll slowly learn as a part of this course. These are kind of goals that we set for our course. Okay, foundations that I'm assuming here is fundamentals of microprocessor and any one microprocessor programming experience or any other kind of a system is okay, but you need to have a good experience. At least you should have a when I say good experience, you should have driven a motor by using one of these controllers or microcontrollers. Okay, if you have done in the closed loop mode, that is great, but even if you have not done, but you have interface some other sensors, is okay. Okay, so that is what is a base foundation I'm assuming. Okay, and we will work in this course on this TIVA board, which is from Texas Instruments, and it is ARM Cortex kind of series microcontroller. So that is what we'll use in this course, with a Code Composer Studio as a emulator or as a software to program it basically. Then you need to have basics of mechanics, kind of in terms of kinematics and dynamics of rigid bodies and particles. Okay, so that is what again will be foundation that is assumed, and your skills in drawing and solid modeling is what will be assumed here. You have enough kind of fundage in terms of drawing. If you see the drawing, you make sense of it, and if you have some kind of a way to kind of do the solid modeling to kind of 3D print some of the parts for your project, you should be able to do that. And then basic skills in manufacturing. Okay, so these are the kind of fundamentals that are assumed. Of course, now we may not have a chance to demand or depending upon when the situation get better, what things that you have locally, depending upon that, these machines may not be used in this project, in this course, probably too much. Okay, but we'll see how we can kind of do some of the things without even having or getting some local access to these things to kind of do some stuff. Okay, these are some of the textbooks for the course, and there is no one single kind of a book, unfortunately. Okay, so have fun in learning this new exciting course on I would say the latest applications, which are kind of this technology is driving this latest application. So you can enable yourself by doing this course to be in the forefront of some of these or many of these applications. Okay, all right, thank you very much.